Hi guys, welcome back to the channel. Jag here. In today's class, we're going to talk about our discussion on calculus and continue on with the first principles definition of the derivative. Okay, so with that, let's get started. So first off, the derivative of a function of f of x is a new function f prime of x. It is defined as f prime of x equals the limit we see as h approaches 0, f of x plus h minus f of x divided by h. Okay, and this is if the limit exists. Okay, so let's try an example here. Let's do example 1. So we're going to start off with a very simple function. It says determine the derivative using the first principles definition. And we're going to try it for the function of f of x equals x squared. Okay, so remember from last year, this is a quadratic function. Okay, if you are to write the domain, of course, we see that the domain is x's all real numbers. Okay, so the first part of this example is basically saying, telling us to state the domain. And then, of course, we're going to use for part B, okay, we're going to do the first principle derivative of this function. So input. Okay, so let's try that. And we're going to use basically this definition of the derivative function. So I'm going to do f prime of x equals, this is the limit as h approaches 0. Okay, so if you look right here, the first time into the f of x equals x squared function, I'm going to substitute x plus h. All right, so we're going to do x plus h squared minus x squared, which is the f of x function, and the whole thing is over h. Okay, also note down that yes, you do have to write the limit as h approaches 0 in every step until I actually substitute the value inside. Okay, so we're going to do limit h approaches 0. So remember, I'm going to just write this out 2 times so we can see. This is x plus h times x plus h. Okay, and then the whole thing is divided by h. Okay, so we do actually have to just kind of FOIL this out. Okay, so we're going to put limit as h approaches 0, x squared. So it says x times x times h is xh, and then again x times h, so 2xh, and this is h times h, which is equal to h squared. I'm going to close the bracket, minus x squared, and the whole thing is over h. Okay, so hopefully everyone sees that. We were just like we were FOILing this out, and we're just expanding and simplifying the numerator. So right here, I see I have positive x squared, negative x squared. I'm going to cancel that out. And what are we left with? The limit as h approaches 0. I'm left with 2xh plus h squared over h. Okay, so of course, as you get really good with the first principles definition of the derivative, you can definitely leave out a couple of these steps. Okay, and of course, what we're going to do now, okay, is I'm going to actually divide each term by h. So this is 2xh divided by h, which is 2x, h squared divided by h, which is equal to h. Okay. And of course, in this next step, okay, what we're going to do is take the limit as h approaches 0. So I'm going to make the h approach 0, okay? So it's basically like 2x plus 0, which I notice here is equal to 2x. Okay, and this is basically using the first principle derivatives and definition, okay, to find the derivative. And all we did was basically use this formula at the very top that says f prime of x, the limit as h approaches 0, f of x plus h minus f of x divided by h. Okay? So hopefully everyone understands how to use this definition of the derivative. Is very important. And of course, there are more simple ways of finding the derivative, like we know, okay, as you go on to the next chapter. Okay, so what we're going to do is let's try one more question here. And put example 2. And this time we're going to let's do our cubic function. It says f of x equals x cubed. This is my function. And I'm going to again find the derivative of this function. Okay, so the limit as h approaches 0. I'm going to do x plus h, like cubed, right? Minus my f of x function, which is x cubed over h. Okay. So also note down, I'm going to show a couple of steps here, because this is basically like you multiplying x plus h by itself 3 times. So first we're going to open up the brackets here. X squared, we said plus 2xh plus h squared. So this is like I multiplied x plus h 2 times. But I have to multiply it one more time, of course. Minus x cubed. The whole thing is over h. Okay, like we see here. The limit as h approaches 0. Okay, so note down here, of course, we do want to expand and simplify. Okay, and then we're going to collect the like terms. So it says x squared times x, right? So x cubed. Maybe I'll make like a small arrow here and lines. X squared times h plus x squared h. Then you're going to the second term. Okay, in the first bracket, you times it by each of the terms in the second bracket. So plus 2x squared h, right, like we see here, plus 2xh squared. Okay, so hopefully everyone sees that. And again, it is the FOIL method. You just have to make sure you're doing it for each of the terms. We're going to go to the last term here. This is h squared times x, so plus h squared x. And this is h squared times h plus h cubed. And then minus x cubed. Okay, I see that the whole thing, okay, is going to be, okay, over h. So of course, I'll definitely show, okay, all the steps here, okay, as I am writing out and expanding the numerator. So the limit as h approaches 0. Okay, I see that the x cubed is going to just cancel out. This is positive x cubed. This is negative x cubed. So it's gone. Okay, and what am I left with now? I'm going to put the like terms together. Make sure you are watching the exponents, okay? So this is x squared, 1x squared h, plus 2x squared h, so 3x squared h. Right here, this is 2xh squared plus 1xh squared, so plus 3xh squared. All right, and here I'm just left with h cubed. So h cubed, like this, the whole thing is over h. Okay, so of course, like you can see that there's h in each of the terms. I can factor it out, but we're not going to do that. I'm going to take the limit as h approaches 0. Divide each of the terms. This is 3x squared h over h, so 3x squared. This is 3x h squared over h, so I'm going to put plus 3xh. And then this is h cubed divided by h, which is equal to h squared. Okay, so if you're wondering where that came from, remember we are just subtracting the exponents, okay, as we're dividing each term. I'm now going to take the limit as h approaches 0. So do you notice that there's an h right here, which is 0? This is h squared, which is 0 squared. Okay, which also goes to 0. So I can see right here, the limit I end up with is going to be 3x squared. Okay? And again, of course, we can see this is my first principle derivative function and the definition of the derivative. Okay, so one more time, all we're doing is we're finding the derivative of the function f prime of x. We're taking the limit as x or h approaches. We'll put 0. F of x plus h minus f of x, and the whole function is divided by h. And you notice you could find the derivative of any function using this first principle definition of the derivative. Okay? And that's it. So I hope everyone understood how to use the actual first principle definition of the derivative. As you go into the next unit or the next chapter, you'll notice again, there are easier ways of finding the derivative, but this is kind of like where the derivative is derived from. All right. So thank you for watching. Please make sure you like, share, and subscribe, and I'll see everyone in the next video. Thanks. Bye.